All right, gentlemen, welcome. This is going to be Sophos XG Firewall on Microsoft Azure. Today we have Jorn Lutters with us. He's a security architect for the global cloud infrastructure. That work well, Jorn?
Absolutely loved it.
So I'm going to go ahead and turn the reins over to Jorn. If you guys have any questions or anything during the presentation, I know everybody is currently muted. Please submit those through the questions. I will be monitoring that throughout the entire broadcast. If you have any questions, definitely speak up. And at this point, I will turn this over to Jorn.
Yeah, and to add to that, I have a slide at the end of this deck as well. So if we have some time left, I'll be answering some of the questions that come in through regular audio instead of just typing this. So with that said, let's get underway. Let's talk about the Sophos XG Firewall, which we've recently launched on Microsoft Azure. But to get the full agenda, let's click here and see if it actually works. I want to talk about two things. The first being Azure Security, the second being XG Firewall. Why is that? Because I feel that these topics are not in and of themselves unique. It means that we need to discuss why you want to have a firewall on Azure before we actually get to that. So the main story here is shared responsibility. Whatever you do in the cloud, there's always a part of the infrastructure that you have to manage. And depending on the type of cloud that you consume, you get more or less responsibility as a result. So to answer the question, why is it there? Because we're just going to have to accept that it's there as a result of how the cloud operates, but why is it there? We need to look at the so-called cloud service model. Now, this is a really nice diagram because it shows you exactly where the responsibility crosses over from the customer to the cloud provider for everything from private cloud all the way to SaaS. It means, for example, that if you're running infrastructure as a service, your applications, your data, your runtime, your operating system is something that you can bring yourself. Excuse me, I seem to be having a small issue with my presentation. There we go. Terribly sorry about that. Anyway, the point I was trying to make is you're going to have different parts of the platform fall under different levels of responsibility. So in an IaaS scenario or infrastructure as a service, you get a lot of freedom. You get so much freedom that you can pretty much bring whatever you want into that cloud environment. That means, however, that if we're going to look at the characteristics of what that IaaS environment is, you'll see that it also comes with some pitfalls because that nearly limitless flexibility of just bringing whatever you have into the cloud means that you can build the craziest things you want or can imagine, but it also means that for the cloud provider, this is really hard to maintain. They have no idea of the operating system that you're running, that you might be running your own custom middlewares, runtimes, applications, everything. So it means that from a cloud provider perspective, it's really hard to manage this environment and to guarantee a particular uptime. So that means that in an IaaS scenario, what most cloud providers will say, be it Microsoft or be it Amazon or be it Google, they'll probably guarantee only up to the part where they can say, well, this is standardized and everything else that you build on top of it is your own responsibility. So that means you'll see things like networking, storage, servers, and virtualization in an IaaS scenario be part of what Microsoft does, and everything else on top of that is your own responsibility. Now, why am I emphasizing this? It means that from a purely functional perspective, IaaS is nearly identical to just renting a server. And because of that, all of the stuff that you need to think about when you just rent a server or have a hosted data center, or if you have a VPS somewhere, applies to IaaS as well. The same thing, to a lesser extent, can be said about PaaS, or Platform as a Service. Yes, there is a lot more standardization. So there will be a standardized operating system, there'll be a standardized libraries, runtimes, etc., and you'll have a limited amount of applications. Reason for that being is, in a PaaS scenario, Microsoft or Amazon, both of them do this, want to have this standardized environment so that they can implement failover, they can implement HA, and they can guarantee uptime, which in turn allows for SLAs, which is something that a lot of people want. So PaaS is halfway between what I would call the rent-a-server model and actual rent-a-service model, which is SaaS. And it might not be for everyone, but these are the two specific ones that I want to talk about, because both of them come with some responsibilities that you need to address when you're going to the cloud. In the case of PaaS, it means that you're responsible for the application and the data and everything that flows in and out of that system. And in terms of IaaS, you've got a lot more responsibilities going. So let's go over them step by step. This is your average PaaS environment. I have a cloud, I have a bunch of users sitting outside of that cloud that might be part of my organization. There might be just some random person with a tablet that ended up on our website, whatever, and I'll have a corporate network that's connected to that cloud via either a express route connection or via VPN or whatever, but you will have a level of interaction. Now, important to remember here is that that cloud is not just a vague, opaque cloud. It consists of services, and each of these services have their own security requirements. Now, in terms of PaaS, when we look back at the previous slides, you'll remember that you are responsible for the application and data. However, because of the different services that you can consume as a PaaS, what does that mean? Well, if we take Microsoft's very nice responsibility diagram, we can start to map out what exactly is your responsibility in this scenario. And in terms of PaaS, you really need to talk about all of the stuff that was orange before. So data classification and accountability, that's your responsibility. That means that everything that comes out of that cloud needs to be stored securely. So if you're storing it on something in your corporate environment, be it a laptop, be it a shared storage, make sure it's encrypted. Make sure that that data is only accessible by the people you want to have access to that data, and make sure you have data loss prevention measures in place to make sure that that data doesn't go anywhere that you don't want it to be. Likewise, when it comes to the services themselves, all of them, well, pretty much all of the services that I'm aware of at least, have some sort of data loss prevention feature built in. Use those to make sure that you are absolutely sure that your data doesn't end up where it shouldn't be. Another thing that a lot of people tend to forget when it comes to cloud is that the cloud is not something that exists in a vacuum. It means that there's going to be a lot of machines interacting with that cloud. And again, that's a responsibility that you need to figure out for yourself. Even in a PaaS environment where the service is guaranteed and the uptime and security of the service are guaranteed by the cloud provider, you'll still need to secure the endpoints. So if you have a server or a set of servers that's interfacing with that PaaS service, make sure that it's running something like server protection to make sure that your on-premise hardware doesn't become a potential entry point for attackers that want to get to your PaaS service, or vice versa. Same thing goes for your local machines. If you have a laptop, it's interacting with a particular service. It might be handling that classified data that I just mentioned. Then make sure you have antivirus on that as well, because, well, every measure is only as strong as the machine running it. So if someone were to, for example, install a malware on your machine that has access to that encrypted data, it could still exfiltrate that. So think about that. Another thing that a lot of people take for granted is identity and access management. And this is because in a PaaS scenario, this is a partial responsibility of the cloud provider. Now, you need to look at Microsoft Service Agreement in detail to figure out why this is a semi-cloud provider, semi-customer responsibility. But what it boils down to is this: Microsoft will provide you the tools to protect the environment. You'll be able to define which users have access. You'll be able to set those policies. What they don't know, however, is who works for you and who should be able to access what. So while they give you the tools, they expect you to use them properly. That also means that if you're running stuff on-premise that interacts with that cloud, make sure that you do your authentication on your local machines as well. Because I mean, let's face it, you can have a secure cloud, you can have it as secure as you want, but if the endpoint that is connected to that cloud does not require authentication, you have no real means of being certain that the person using that endpoint is actually the person currently logged in to the cloud through that endpoint. And that also goes for traffic that comes in from external sources, because this is even harder. And this is where you'll see the XG Firewall come in a bit, because it's one of our very common use cases. It is use some sort of solution to pre-authenticate traffic going to those PaaS services. Not just because you want to protect the PaaS service itself, but because you want to have logging of what went on there. And one of the ways to do that is not just trust the SSO for the actual application, but to put a web application firewall in front of a PaaS service, and most of them actually support this, and do your authentication there. And lastly, when we're talking about PaaS, we need to address application level controls, because again, this is a gray area. And again, same thing applies. Microsoft provides you with the tools. You are responsible for wielding those tools properly. That also means that if you're going to have API access to those particular services, you want to make very, very sure that no one is going to execute commands against that API without at least you knowing about it and having some sort of logging. So what I would normally suggest is, even when we're talking about a connection to a corporate network, is to also have your XG firewall there sitting at the edge of your virtual network, making sure that everything that goes in and out is scanned by the IPS, by the web application firewall, if applicable, just so that you're on the safe side. And then we get to the really, really hard bit, because in IaaS, you have all of the challenges that I mentioned about PaaS, but now we're not talking about services. We're talking about, like I said, rented virtual servers. So instead of a opaque cloud of services, it is boxes that you need to manage. And this is very neatly reflected in the fact that when we take this responsibility diagram again, you'll see that most of it is blue, meaning you are responsible. So when we're talking about data classification and accountability, absolutely, you are responsible, with one big difference being that in the PaaS model, you normally have some sort of built-in accountability. Well, because IaaS is a bring whatever you have, bring whatever you want, or even build your own environment, you will need to bring your own data accountability and classification tools into that cloud as well. So that means that if you're going to be producing any sort of sensitive data there, you need to have a solution. And yes, of course, you also need to have that solution work with whatever stuff that you might have in your corporate environment that interacts with those servers. So that might be shared storage, that might be laptops. Same thing as we saw with PaaS. You need to make sure that you have a solution in place that manages that responsibility. Endpoint, same thing as I said with PaaS. You have machines interacting with this service. You need to make sure that they don't become an attack vector for your cloud or vice versa. And specifically with IaaS, vice versa is something that you really need to think about, because you're running a bunch of virtual servers. You are not consuming a service. So that means that all of those virtual servers that you're running in the cloud, they will need to be protected as well. And the good news is, with, for example, Sophos server protection, you can actually protect those Azure virtual machines and make sure that this is indeed taken care of. Another thing that is a lot harder to do in IaaS as it is in PaaS is identity and access management, because we're not talking about services, so Microsoft isn't providing you with the tools to do the authentication. You need to build this yourself. That means that you'll need to set up something like Azure AD or a server Active Directory or whatever other authentication mechanism that you want to use, but it means you're going to have to build it. It also means that this applies not just to your local environment, but also to your cloud environment and to the people coming into that cloud environment. It's the same thing as with PaaS, but with the amount of work and the risks dialed up to 11. Same thing applies to the application level controls. Again, you are responsible for those applications. Microsoft doesn't know them. In fact, you may not even have a backup service for that application. With PaaS, what happens is if someone crashes your database, you just restore a database from a backup that you have. With your own IaaS environment, you are responsible for that backup. Make sure that you have it. Make sure that you can actually restore from those potential tragedies. And that also means that traffic going in and out of this environment needs to be scanned by an XG firewall or whatever security service solution that you want to use to make sure that you do not let the attackers go into this environment unfiltered and change things that you might not want them to change or see things that they should not see. And then we venture into network controls, and this is where IaaS really becomes a different ball game to PaaS, because with network controls, what the cloud service providers tell you is, well, here's the tools. You are in control for the network. That means you're responsible for routing. It means you're responsible for firewalling, IDS, IPS, advanced threat protection, the whole thing. So even if you weren't considering having that XG firewall for the WAF or for that application level scanning, you're gonna want to have one to be able to cover this responsibility, because the tools provided by Microsoft, while good, are not perfect. They are, I would say, the equivalent of a traditional firewall. They're stateful, you can open ports, you can close ports, and you'll get logging for which IP addresses interact with those ports, but that's all you get. So you're going to have to bring your own solution if you want to get more visibility and better protection. That also means that you're going to have to set up some way for the remote devices to connect to your environment securely. Yes, Microsoft again provides some solutions. For example, the VPN services in Azure are absolutely splendid. The problem is they're also limited. So they provide, for example, a really neat IPsec connection that works with every machine that's running Windows 7 or over. However, it is based on IPsec and doesn't work with all versions of Windows. If you're going to talk about secure connections into your environment and VPNs, again, this is where you'll need a third-party solution, such as our XG Firewall, to build things like SSL VPNs and to minimize the amount of work that you need to do yourself to deploy these VPNs, because with the XG, you can use the user portal for that. And then lastly, we get to the host infrastructure. And even here, it is not all the responsibility of Microsoft, because what Microsoft's service agreement very neatly states is they are not responsible for the uptime of your machines in IaaS. If you want to have your machine be highly available, you need to build a highly available machine. That means using availability sets. It means that you need to set up monitoring, and again, it means that you need to do all of the other things you would normally do for a hardware server. That means backups, patching, software testing, etc., etc. Right. So that was a bit of theory on how the cloud works, why we have shared responsibility, and what that means in practice. So to address a lot of those issues, we have solutions. We have our safeguard to do our encryption. We have our server protection to protect the servers that are actually running it. So you'll have those servers right to secured storage, and that can then be accessed by your users that are running a secured laptop with our endpoint on it, or a secure mobile device using using Sophos mobile control. But that's not the end of it. As you've seen in the previous slide, a lot of the more advanced setups rely on having a firewall in place. And this is what we did with the launch of the XG Firewall on Azure. We brought our firewall there so that you have network level control of what goes in and out of your environment. Now, why do we do that? Well, we address 5 particular use cases in cloud with the XG Firewall. One being indeed firewalling and IPS. Like I said, the security groups provided by Azure are really good. In fact, if Microsoft had launched this as a product, say in 1998, I would be out of a job because it's a really good firewall. But it is not a really comprehensible firewall. It doesn't have a graphical interface. It doesn't have the ease of use of a mature firewall product like our XG. It also doesn't come with IPS or advanced threat protection. So that's one of the main use cases that we have when talking about cloud with customers. Another thing is remote site VPN connectivity. Again, Azure provides some really good built-in VPN services for IPsec. However, they're not perfect because it's built around IKV2. Now, a lot of legacy devices will not support IKV2, so this is where you can put an XG firewall in place to provide IKV1 connectivity. Another thing that Azure didn't support for a really long time was the use of BGP over those IPsec connections. This is again something that we can address with the XG firewall. And lastly, and one of the things that Microsoft hasn't addressed themselves yet, is actual failover of that VPN connection. So with Azure, you can have multiple VPN gateways that fail over for each other, but that's only on the Azure side. If you want to have multiple VPN gateway failover on your local end, that's where the current solution stops. So if you have multiple ISPs and you want to connect to Azure through your primary ISP, unless that fails and then fail over to a secondary ISP, you're going to have to need to build a third-party solution, again, something that we provide with the XG firewall. Similarly, the client access VPN use case is also really popular because IPsec VPN as provided by Azure for clients is really secure. However, it's also very inflexible. It means that the firewall that your current user is sitting behind needs to allow that particular type of traffic, whereas most people these days will probably be working from a Starbucks or from an airport or from wherever, and they will expect their VPN to work even without the administrator opening different ports. This is where solutions like our SSL VPN come in, where you can just set up a VPN regardless of the environment. As long as you have internet, you can actually VPN into the environment. And it's also a lot easier to configure than the Azure VPN because the user can just go to the user portal, download a small package, run it, and be ready to roll. Another very popular use case is web application firewalling. Again, Microsoft provides some really neat tools in their application load balancer that do all of the, I would say, standard WAF stuff. So they'll filter for the top 10 OWASP, they'll do all of the regular SQL injection and cross-site scripting checks, but they don't provide the same level of security that the XG Firewall does, in that we can pre-authenticate people going into your environment. In fact, we can offload the authentication for your entire backend. We have antivirus not just for uploads but also for downloads, because what's worse than being infected? It's infecting another 10,000 people through your public web page, because that last one probably ends you up on some sort of headline. So Yes, very good tools, again provided by Microsoft, but with limited functionality when it comes to detailed cases. So Web Application Firewall is definitely one of the use cases we see a lot. And lastly, outbound web filtering. And this is where, in my personal opinion, Azure really doesn't shine because there is no real outbound filtering. So let's say that you built your RDP server farm on Azure and your users are connecting to it. You need to have a solution in place that makes sure that they are not going to go to particular websites that you don't want them to go to that will scan the incoming traffic. So this is where the XG firewall is often used as the gateway to do that URL filtering, to do that application filtering, and to provide that inline anti-malware. Right, so where and how do you place an XG firewall then? Well, this is where we get into virtual network design. As you know, Azure uses VNets or virtual networks as, I would say, the logical equivalent to Amazon's VPCs or virtual private clouds. It's basically a small slice of Azure that is for you and you alone, and you get to determine who has access to that particular environment. Now, the good thing to know about Azure is that a lot of the things that I just talked about, be it IaaS or PaaS, are compatible with VNets. So cloud services, most cloud services can be loaded into virtual networks without issue. Same thing goes for worker roles and web roles, as well as virtual machines. So with that virtual network set up, you have an environment that uses private IP addressing and that is ready to then have a gateway in the form of an XG firewall. Now, this is what we then also suggest as your proper design. So when we take a look at the whole VNet structure as it is, you'll have people hitting the outside of this particular VNet in the form of a traffic manager if you have multiple sites, so you can geo-load balance this environment. Then they'll hit a network security group on the I would say on the periphery of the virtual network, and then you can forward that traffic into an XG firewall. Now that XG firewall is versatile. So this is what I would like to call the security tier of your virtual network. So if you have traffic coming in through ExpressRoute, or if you have traffic coming in from a Azure VPN gateway, you can route that to the XG firewall, similar to how you would route the traffic that comes in from the internet to that XG firewall, and filter it before it actually reaches either your identity tier or your app and data tier. Now, if you need high availability for that XG firewall, we can use the Azure Load Balancer to provide failover or additional nodes for that environment. Then, of course, the next thing that we can do is use the layer 8 technology that we have in the XG firewall to communicate with your identity tier, where you'll have something like a Microsoft Server Active Directory set up to authenticate that traffic coming in before we then forward it on to the actual app and data tier where your virtual machines and your various cloud services and roles live. And this is also where we get to really crank the dial on the IaaS security with not just having server protection running on our virtual machines and an XG firewall as, I would say, the front door to this environment, but because of the fact that we have the security heartbeat, we can do something that's really neat. Let's say that someone does indeed manage to compromise one of your virtual machines. With this particular setup, the XG firewall can eliminate the connection from that virtual machine to any other role in that app and data tier by setting up your VNet in such a way that it will route the traffic through that XG firewall. Or if you have a really large environment, you could even have your VNet peering done through VPN gateways instead of direct VNet to VNet peering, so that you can have not just your, excuse the term, north-south traffic scanned by a firewall, but also your east-west traffic, being traffic that goes from one VNet to another through that firewall. And with the heartbeat as soon as something goes wrong, we can immediately isolate a particular node from the network instead of having to assume it's not going to attack other virtual machines. Another thing that we brought to Azure that is really unique is the zone structures. So as you know, with the XG firewall, you can use security zones to basically combine networks into a general policy area. And because Microsoft does not support the use of VLANs in a virtual network because there is no layer 2 separation, this is a really nifty way of working around that limitation by using the XG file to build this particular isolation. So you'll be able to set up a LAN zone and then create your own DMZ zone, WAN zone, services or web zones to make sure that all of these particular components of your infrastructure do not talk to each other unless explicitly allowed by the XG firewall. So that's a lot of talking, and I understand that a lot of people will now probably be hoping that I actually get to show something. So that was the technical demonstration, or what I would say technical presentation part, and let's now get to the demonstration. So let's grab my browser here. That's the wrong one. There we go. Okay, so here's how we set up an XG firewall. We start off at the Microsoft Azure dashboard, as everyone does, and it's really simple to go from there. So you just go to your virtual machines, you add a virtual machine like you would with any other, and then after a small delay, I hope, it should load the marketplace. Okay, it's still loading the marketplace. This usually doesn't take all that long, but of course, when you are presenting something like this, it tends to go 10 times slower than reality.
Yeah, it usually figures that we have these kind of delays when doing live demos. If anyone
Yeah,
has any questions while we're waiting, I mean, feel free to put those in the questions below, and I'll be happy to read those off to Jordan as we wait for this to populate.
yes, that would be great. I am, by the way, signing in with a different browser right now, hoping that that's going to be a bit quicker.
Yeah, we did have somebody recommend using Edge. I guess using Microsoft products with Microsoft Azure probably works better.
Yes, however, I'm running a Windows 7 machine, so Edge is really not something that I can currently support. However, Internet Explorer, good old Internet Explorer, is loading, so let's try it there as well and see if that goes any quicker. In fact, it does. So onwards with this presentation. So anyways, sorry for the interruption. The marketplace is now loaded, and the good news is that if you search for Sophos, it will automatically pop up with the Sophos XG firewall as a suggestion, or if you hit enter, it will show you several different Sophos options. Now, the one that we want to deploy is the Sophos XG firewall. In case you see the other three, this is a bit of a bug that we have discussed with Microsoft. These are components that are normally used by our solutions template. So what you want to do is, if you see those, just ignore them and go for the item called Sophos XG Firewall without anything in brackets or whatever. So when we click that, it will open the new blade, and we get to read about the XG Firewall, how the pricing works, etc., etc. Now, I'm not going to bore you with that. Instead, I'll just go and click on Create. And this is where we get to how the template works. So one of the things that we've done with the XG Firewall when we brought it to Azure is we figured that a lot of people do not have an environment yet. So what our template builds is not just an XG Firewall, it is also the virtual network that is needed to support that particular XG Firewall and the network and the subnets inside that virtual network to host your clients. So let's start by giving this a VM a name. Let's call this XG Demo North America. Next up, we're going to want to set only contain numbers and characters. Of course, Sean. This is one of the neat features, by the way, of Azure. If you enter something wrong, the check will automatically tell you why it's wrong and you can correct it. Next up is the password field. This has complexity requirements because this is the same password as you will be using to log into your XG Firewall once it has been set up. So what you want to use is both uppercase and lowercase characters, and preferably some digits or punctuation marks. Next, you're going to want to repeat that. And then it'll ask you about the subscription. Now, this is our own demo account. If you have multiple accounts, and you can select one from the drop-down. Next up is the resource group. Now, a lot of people have asked in the past why we do not allow people to reuse existing resource groups, and the reason for that is this does not comply with Microsoft architecture best practices. What Microsoft specifically suggests is using different resource groups for everything that you build, so that when a particular resource is down, a particular part of Azure is down, your entire environment isn't affected. So this is why we suggest you build a new resource group, which I'll do right now. And then we get to select where we want to host this machine. And as you can see, we currently support all regions of Azure. So regardless of where you are, be it in the US, be it in the UK, be it wherever, we can support that. So in this next step, we'll look at the actual instance that we're building. Now, the first question is the license type. We have BYOL and PAYG. Now, BYOL is bring your own license. This is pretty much any old regular XG license that you have for a virtual machine. You can just buy that through the partner landscape, apply that, and you're good to go. The pay-as-you-go is a bit different because this is an hourly billed license that provides a full guard subscription to your XG machine that you pay on top of the operations costs of the VM that you're running. Now, this is very interesting for small size demos, for smaller environments that you want to build, but it does come with some potential drawbacks in that it is not available for all regions. In fact, currently we only support it in the US, in the UK, and in mainland Europe. So any region outside of those is currently not supported due to taxation regulation, which is really boring and something that I would rather not go into during this presentation. However, one of the things that I do want to show is how this then influences your pricing. So in the next step, you get to select the virtual machine size. Now, because of the built-in running cost calculator, Whenever you select a particular instance, it will immediately tell you the price of that particular instance when running for this solution. Now, of course, when I say this, it's probably going to load forever. So while that's loading, one of the things that you do need to remember when building out the XG firewall is that it requires you to have a virtual machine with at least 2 network interface cards. We can support any size instance as long as it has at least 2 NICs. Any less and your machine will simply fail to deploy. Our recommended default is selected automatically, which is the D2V2, which has 2 cores, 7 gigs of RAM, but the reason we selected over the A3, which has more cores, is that it comes with its own SSD. So this is really crucial when it comes to performance. Now, the thing that I wanted to show is that this is the regular operations pricing. You'll see that this machine will cost me 63 quid. If I switch to pay-as-you-go and I close this blade and then click this again, it's going to immediately show what the pricing would be for that particular instance if I were to have the license billed through Microsoft. Now, for existing Sophos partners, this is very interesting to know that in the pay-as-you-go model, we do not have Enhanced Support Plus. So if your customer requires higher levels of support, then it's very interesting for them to switch from pay-as-you-go to BYOL. Another reason is that when compared over 12 months, the pay-as-you-go license will usually be somewhere around 10 to 15% more expensive than buying a yearly BYOL subscription. However, now that it's done loading, you can see what I wanted to show you is that it will show you what this machine will now cost you per month with the license for the XG included. So let's go ahead and select a machine, and then in the next step, we'll build your virtual network. Like I said, we're going to assume that you don't have one, so we'll create one for you, and we are very good at naming things, so that's why we have called your VNet VNet by default. Now, of course, if you want to, you can click on it and change that, or if you're okay with that, you just leave it as B, click OK, and continue. Now, another thing to note is that you can also set your own address space, which is very neat if you have multiple environments and if you want to get your VNet to VNet peering to work correctly. However, do keep in mind that you need to have room for at least 4 subnets of /24 size in your VNet for this particular configuration to work. So next up, we're talking subnets. Again, we're really good at naming, so we'll name the one subnet 1, we'll name the LAN subnet LAN, and we'll pick the first and the second possible subnet in the VNet range. Very, I would say, original. Now, of course, you can modify this. You can modify the name, you can modify the subnet to whatever size you prefer, or you can just click OK, accept the changes, and move on. Now, because the XG is going to be reachable from the internet, we're also going to attach a public IP address to the one interface. Now, again, we're really good at naming things, so we called the public IP public IP. What I would suggest is by default we use a dynamic assignment, which is really great if you just want to build a standard demonstration, you just want to set up a machine and get going. However, if you're going to build something that's actually going to be reachable from the internet at some sort of consistency, so it shouldn't change its IP address if you reboot it, then please set the assignment to static. Also, you can change the name because, well, yeah, everything can be changed. So that's the public IP. Next up is your domain name, and this is the public name that Azure is going to assign to the IP address that you have just requested. So this needs to be unique, and it needs to be a proper part of the domain of the fully qualified domain name. So you're going to enter the host part. So in this case, we'll use xgdemo North America, and that will then turn into xgdemo northamerica.uksouth.cloudapp.azure.com as the default A record assigned to this particular machine. Lastly, we can set the storage account. Again, recommended practice by Microsoft is to not reuse storage accounts for different roles. So if you have two XG firewalls that need to run in tandem and perform failover for each other, use different storage accounts, because that means that if the storage that is running your primary XG, let's say that has an issue, goes down, crashes, whatever, you do not, under any circumstance, want to have your secondary XG run on that same storage account, because that will be dead then too, and you're stuck without firewalls. You do need to supply your own name. In this particular case, we do not set the name for you, because storage account names need to be unique and will be, again, part of a fully qualified domain name that ends in .core.windows.net. So usually you want to go for something that is properly unique. There we go. Now, the one thing to remember is that we only support standard performance storage, because booting machines from premium storage is not recommended from a troubleshooting perspective. Now, we do support both locally and geo-redundant storage. And for those of you who have participated in our public preview, we had support for geo-redundant read-only storage, but that really didn't make sense because, well, the machine's going to write to somewhere, obviously, so we want to make sure that we actually manage to have read and write storage when we do that. For all intents and purposes, this machine should never need geo-redundant storage, because let's face it, this XG machine is only as good as its configuration. So if it crashes, you just build a new one and import the configuration, versus trying to restore a backup that's running in, let's say, Australia or somewhere. Right, so with all of that filled in, you can click OK, and you get a very nice summary. It's actually really quick. That's neat. So while this summary is displayed, it will also run a final validation of the template. It will check if all of the names and the passwords and everything you filled out is actually correct. And as soon as it says validation passed, you can hit OK and proceed to purchase. Now, I like the summary because you can just take this little tidbit of information and save this in your documentation to just say, to just know, hey, this is this machine, these are the specifics of the network, etc., etc. It's just, I would say, a very nice overview that you can use if you have a large environment to just keep track of your machines. Last up is the buy page, and this takes a bit more time to load, but it will show you the Sophos XG EULA, and it will ask you to review the terms of use and our privacy policy, etc., etc. If you agree, hit purchase, and it will start to build a machine. So while this is building out my machine, let's go to one that I've already deployed in my virtual machines, which is called the JLXG test. And as you can see, once the template finishes building your environment, you will have a very nice VM in its own resource group with all of the specifics that we have just discussed. Now, this is not the end of it, however, because Azure is its own very specific creature. So with a regular on-site network, what you would now do is go to your particular virtual machine, point the default gateway at the XG Firewall's internal LAN adapter, and say, well, use this if you want to go to the internet. You can do this in Azure too, it just won't work. Now, why won't it work? Well, that's because of route tables. Microsoft specifically wants you to use the route table function in Azure to do that. So we have built our XG. Now let's get our machines to connect. Now, the first thing that we want to do is go to our network interfaces and make sure that we set a static IP address for the port A interface. The port A interface, by the way, is the default LAN interface. If we use the default template and we use the default LAN network, it's going to use port A as its default LAN connection. So we're going to open the VM, click on the network interfaces, open the port A interface, and then go to the properties. To the IP configuration. Sorry, it's my bad. And here we will be able to set our IP address. Now, by default, this is going to be assigned dynamically. We want to change this to static. Now, you can set your own IP address, or you can just leave it at whatever we selected automatically and hit static. The only reason that we're here is because we're going to reference this IP address in a bit in a route table. And the last thing you want to have is have your machine reboot, get a different IP address, and have all of your machines no longer be able to reach the internet as a result. So this is why we're going here. We'll configure it as static, and we'll leave 10.6.1.4 as
Jorn,
the
just
static IP.
real quick, in case people don't already know this about Azure, the reason why it's not .1 in there is you do have reserved IP addresses. So if you do set this to 1.1 inside of there and you notice it's not working, it's going to be because Azure has those as a reserved IP.
Yes, absolutely, and the same thing goes for 254 at the subnet as well, because that's reserved as well. So yeah, good thing that you brought that up. All right, so we have this IP address. Now we're going to go to our route table, and this is the last step that you need to do to actually get your machines to connect. So what we want to do is we want to create a new route table. So let's call this XG demo NA route. We're going to want to put it in its own resource group again. And we're going to want to select a location for that. So then we can hit create. And after a usually really short period, it should pop up as a new route table. And there we are, we have a new route table. So then we can go to that route table, and we need to do two things. So the first thing we want to do is we want to go to subnet and associate it with the particular subnet that we have just built. So we click on associate. We'll select the virtual network that we created, which, as you remember, was called VNet. And then we'll select the subnet in that particular VNet, which is LAN, because our LAN machines are going to be using this. We'll hit OK. And then next up, as soon as this is complete, it should show as the associated subnet. Yes, there we go. Now I have my LAN network, which will be my 10.12.1.0/24 as we've seen in the template, and it will use this route table. So the last step that we're going to take is then create a route for public traffic. So we're going to want to set a route, give it a very creative name. I'll usually just call it default. Set the address prefix. So this is the default gateway, so we're going to want to send 0.0.0.0/0 to this particular next hop. And as the next hop type, we're going to select the virtual appliance, and this is where we're going to enter the IP address of our machine that we have just statically configured. We hit OK again, it will update, and as soon as that's done, there you go, you'll have a new default gateway route that's actually going to point to your XG. And now your XG machines, so the ones that you actually have sitting in this particular virtual network, will use the XG firewall as their gateway. And as strange as it sounds for me to say this, if you do not do this, it will not work. Even if you statically configure the gateway on your machine, it will not reach the XG firewall. So this is a crucial step in setting it up, and the whole reason why we didn't include it by default in a template is in case you have a more complex environment, let's say that you have VNet peering set up or some sort of route integration that you might have with an on-premise network, if we were to just randomly generate a bunch of routes for you, we would probably mess up your environment. So that's why we don't like doing that. So with all of that said and done, the only thing that you really need to do then is go to your XG and configure it as usual. So we can log in as our admin and we can use the password that we had just defined in the template. Log into this machine. Now, if this is the first time login, you're also going to see your EULA again. You're going to have to accept the terms of use. You're going to have to sync the license, etc., etc. Now, I hope that I don't need to do this. But anyways, this is not the interesting part of what we're talking about because this is just a regular XG firewall, and you can configure all of the regular things that you would do with an on-premise virtual XG firewall as well. So there is no particular difference there. So with that said, and looking at the time, I'm going to go back to my presentation and move to the all important questions slide. So I don't know if any questions came in.